Linda's laboratory is always working toward improving their processes. In order to do so, methods and instrumentation must be reviewed and updated. As equipment gets older, it may not stand up to the rigors of increased sample throughput. Concerns such as speed, effectiveness, as well as outdated safety measures need to be assessed. Looks like it might be time to upgrade Linda's evaporator technology. Linda knows that a rotary evaporator is a staple in any lab which requires sample concentration and solvent extraction. Some questions must be addressed when deciding which rotary evaporator is the best fit for the application. The type of sample, heating and cooling capabilities, automation, accessories, and safety all need to be considered. Sample type will play a pivotal role in the configuration of the rotary evaporator. In order to work effectively, a vacuum pump is used to lower the temperature at which a solvent will evaporate. Knowing which solvents need to be extracted will help choose the amount of total vacuum required. The ability of the vacuum pump to resist damage from the solution being evaporated should also be considered. There are a variety of solutions available to make sure the vacuum pump being used is coated to resist damage from a variety of chemicals and reagents. Heating and cooling capacity is an important factor when selecting a rotary evaporator. For efficient solvent removal, the temperature differential between the heated solution and the condenser must be sufficient to enable collection. Many different options exist, with typical configurations being dry ice condensers or circulated tap water. Recirculating chillers can also be used with rotary evaporators. These units are more efficient at cooling than their counterparts, do not require constant refilling of dry ice or water, and are more environmentally friendly. Streamlined workflow, increased sample throughput, and freeing up of researcher time are some of the advantages of automating your rotary evaporator. A variety of options exist to make the process more efficient. These include motorized lifts, automatic boiling point detection, programmable evaporation protocols, and automatic speed-controlled vacuum pumps. Some accessories can also increase sample throughput and efficiency, such as spider holders or powder flasks. These allow simultaneous evaporation of more than one sample. Having a rotary evaporator which is efficient and reliable is important, but safety should always be considered when purchasing any lab equipment. Foam brakes ensure samples don't bump and spill into the collection vessel during the evaporation process. Coated glassware can prevent shattering. Unique safety features such as an adjustable safety stop that stops the lift before it can damage the evaporation flask, and shields or protective hoods can be purchased to ensure operator safety. Beyond accessories, programming functions can also ensure safety. Shut-off procedures can stop the instrument if the bath goes dry, as well as lift the flask if a power outage occurs. Satisfied she has made the right decision, Linda is ready to purchase her new rotary evaporator. And with fully automated functionality and walk-away capabilities, Linda is free to imagine new possibilities. Lab Manager. When we talk science, we mean business. Brought to you by